Page 63, operations on polynomials. Start by reminding ourselves about like terms. We can combine like terms if they have the exact same variables raised to the exact same exponents. So which of these are like terms? Well, 7x cubed and, oh, this negative 8x cubed. Any more x cubes? No. So there are some x squareds, but those have different exponents. Okay? Let's look for 7x. Any more 7x's? Or I shouldn't say 7x's, I should just say x's. I see an x cubed, I see an x squared, but no plain x's. That's its own, that's the only like term for it. If you like to use color, you can go ahead and do that. If you only have one marker, you can also show it in different ways. So 7y, maybe I'll do a zigzag. I'll do that zigzag for 9y. For negative 3x squared, maybe I'll circle it. And 8y squared is just its own thing. Maybe I'll put a box around it. So lots of ways to represent. And then if you were to combine all of these, you could say, okay, I want to combine these two blue ones, combine these two zigzag ones, and the other three are just themselves. Take a moment to figure out which of those are like terms below it. And then we'll meet up on some examples. So 4x squared minus 12xy plus 9y squared plus 25x squared minus 32y squared plus 4xy. Let's take a look at that. First thing I'm going to do is realize that those parentheses are just saying add this thing to this thing. They actually don't even really matter. So I could rewrite them. I could even just erase them. So let's do that. Feel free to rewrite it if you've written in pen. Okay, so now I just have a bunch of terms. Let's do the same thing that I did up here. 4x squared. Is there another x squared term? Yes, right here. Notice that I get the sign before as well as that term. Negative 12xy. Do my zigzag here. Any more xy's? Yes, plus 4xy. Again, getting that sign. And finally, plus 9y squared. Do a double underline and a double underline here. And now I'm going to ask myself, okay, what comes first? Pause and think for a moment. What comes first? Well, the x squared term has x to the second power. This has x to the first power. This has x to the 0 power. It's not in there at all. So this part was in the right order. Now we just have to throw those in. So 4x squared plus 25x squared gives me 29x squared. Minus 12xy plus 4xy. So minus 12 plus 4. We're adding things with opposite signs. So we take the difference, which is 8. We figure out which sign we need. We need the sign of the bigger one with absolute value. And the xy goes along. And then 9y squared minus 32y squared. We're taking a little number minus a big number, so we'll have something negative. And then 32 minus 9, the difference in absolute values is going to give us the 23 that we're looking for, 23y squared. Notice that 9y squared minus 32y squared, the y squared is still multiplied by that coefficient. So the y squareds don't disappear. X squared plus 2x squared, well, so for example, 3x minus 2x equals x. The x's don't disappear. It's not just one. Okay. Example 2. Minus 5a plus 7 plus 4a cubed minus 8a cubed minus 2 minus 3a squared. Now we can't just do our trick of deleting the parentheses again because we're subtracting. And if I want to subtract this whole thing, that looks different because I'll have to distribute that minus sign. I could drop these parentheses though. Let's go ahead and do that. Minus 5a plus 7 plus 4a cubed. And now I'm going to take this minus sign and distribute it to each term. So we're subtracting 8a cubed. We're negative times negative is positive, adding 2, and we're adding 3a squared. Now we have something that looks like example 1. So go ahead and take a minute, figure out what the answer should be. Pause the video, and I'll give you the answer. So you'll do some work to figure this out, but your final answer should be negative 4a cubed plus 3a squared minus 5a plus 9. Notice that these are in order: a to the third, a to the second, a to the first, and a to the 0. Let's look at 3c plus 5d plus d minus 3c. Something just a little bit unusual happens here. You can handle it though. Example 4. 3x to the 4th y cubed minus 2x squared y squared plus 5x cubed y squared. I want to take all of that and subtract negative 1 plus 4x cubed y squared minus 2x to the 4th y cubed minus 2x squared y cubed. Wow, lots going on, but it's similar to number 2. So go ahead and treat it like we did number 2. Those parentheses we don't have to worry about. This negative sign applies to every term. There are 4 of them in here. Combine like terms and put them in order. And when you do put them in order, remember that you're looking for the x to the largest power first. That would be x to the 4th. Then you take care of all the x to the 4ths, then all the x cubed, then all the x squareds, then all the x's, then all the constants. And those may not all be in there. Then you just skip over. Example 5. Look at some multiplication. 5x times 4x squared plus 3x plus 7. You can distribute using those little arcs that we've done before. Here's my favorite way to do it though, because this applies to when we have more complicated stuff at the beginning. So this will work for both situations. Something simple at the beginning and something more complicated. So what I do is I make a little chart and I put the left piece on the left and the right piece along the top. I could have switched them, it doesn't really matter, but that's how I tend to do it. And then I like to use a different color to keep track of what parts of my chart are from here and what parts are from multiplication. Now I'm going to ask myself, 5x times 4x squared. What is that? I want to figure out this product. So 5 times 4 is 20. X times x squared is x cubed, because that's a 1. 1 plus 2 is 3. Plus 3x, so that's plus 3 times 5 is 15. X times x, x squared, plus 7 times 5x, plus 35x. And there's my answer. I can just read it off in this particular case. 20x cubed plus 15x squared plus 35x. No like terms to combine, so I'm done. I found my answer. Let's look at another one like that, because this chart method, this may be how you've always done it, this may be a little new. Let's look at, whoops. So example 6, negative 7x squared 2x minus 5x squared plus x. Okay? So there are a few ways to do this. I'm going to start by making my chart again. I have negative 7x squared out on the left. I have 2x minus 5x squared plus x across the top, just straight from here. I'm going to make my chart and then do multiplication. So this cell here gets the product of what's on the left and what's above. Negative 7x squared times 2x is negative 14x cubed. This gets the product of what's all the way to the left, negative 7x squared times what's above, plus 35x to the fourth, plus x times negative 7x squared, negative 7x cubed. It's not in order. Got to do a little work. And in fact, we can even combine some like terms. So when I rewrite this, I'll do my x to the fourth term first. So 35x to the fourth minus 21, because those are both negative, x cubed. There's my answer. What I'd like you to do next is go back, look at this second term, or this second factor, 2x minus 5x squared plus x. We combine like terms down here. What if you combined like terms up there? Try it. Take this expression, combine your like terms first, and then you'll have some easier calculations. You should get the same answer. Okay, example 7. Let's look at 5x squared y times 2x squared plus 5xy minus 10. I'm going to do the same thing. This doesn't have any pluses or minuses in there, so I can just, it's all one term. 2x squared. This is in order, no like terms combined like that one, so we'll just leave these alone. Okay. Let's find the product of the blue numbers. Product of the blue numbers again. 5x cubed y squared. The product of these, negative 50x squared y. Got two questions for you. One, if we did not have like terms up here, could we have like terms here? Pause it and think about it. If we can, check and make sure that we don't have any. And then make sure that this is in the correct order, or think about whether you need to rewrite it. Okay, let's take a look at the next, I'm moving on to the next page. Well, I guess I've got room for one more. Feel free to move on to the next page whenever you're ready for it. I'll do example 8. Sorry, I am going to move on to the next page. It lets me. Okay, example 8. Now we're going to take a binomial, remember that has two terms, times a binomial, instead of just a monomial multiplication like we did on the previous page. So this looks a little different. I have my x, I I have my plus 4. So I'm going down the left side. And then I have my 2x and my plus 2, just like I did before. So now instead of just one row, we've got 2 rows because we had 2 terms. We're going to do the same thing, multiply the blue numbers. So I have 2x squared plus 2x plus 8x plus 8. Even though I didn't have like terms in here or in here, I do now. Think about why that might be. Then go ahead and combine them. We get 2x squared plus 10x plus 8. Example 9. 4x minus 10, 2x plus 3. I'll set this chart up for you. 4x minus 10, 2x plus 3. You go ahead and fill in the 4 cells here. Decide if there are any like terms to combine. Decide what order they should be in. So finish it off. And I'll continue with example 10. 4x minus 7xy, 2y plus 3x. I noticed that 2y plus 3x is out of order. So that means that my final answer is going to be out of order unless I do some rearranging, either now or later, or maybe both. Let's look at 11. 11 is 2b minus 3 squared. Well, you may remember that we talked about how this is not just squaring this part and squaring this part. But what is it? Well, squaring something is multiplying it by itself. So let's rewrite this like so. Now we can put it in a chart just like we've done above. I'll let you finish that one off. And we'll talk about number 12. Here we have a binomial times a trinomial. So our box is going to get bigger. We have 2p minus 1, 3p squared minus 3p plus 1. Notice that the symbols always, the signs always go with what's right after them. 6 boxes this time, because we have 2 terms here and 3 terms here, 2 times 3. Okay? Once we have this set up, we can calculate, we can find our like terms. There should be 2 sets, I believe. And then we can write our final answer. Example 13. 3x minus 2. 2x squared plus 4x minus 11. I'll let you set that one up and solve it. And then let's take a look at example 14, which involves division. This first one, we've done something like it already. Remember, we just divide the coefficients, subtract the exponents when they have the same base. So this is 10 divided by 2 is 5. Y to the 5th over y squared, that's 5. Y to the 5 minus 2, which is 3. Okay. So we're looking 3. 15, similar. I'll let you work through this one. Notice that your answer for this will either involve a fraction or a negative exponent. And what does that mean about the answer to this? Think about it. That it's not a polynomial. The answer is not a polynomial, even though we divided a polynomial by a polynomial. Example 16, 27 y to the fourth plus 6y squared minus 18 over negative 6y. Here's how I like to do these problems. If you remember, a long time ago, we did things like 2 sevenths plus 3 sevenths equals 2 plus 3 over 7, right? 5 sevenths. What does that have to do with this? Well, I'm taking something that looks like this, right? Kind of, and turning it into separate terms. I'm breaking it up. So I'm going to put every single term here over the negative 6y. Try it out. This is the same as 27y to the fourth divided by negative 6y. I can divide each term individually. As long as each term gets divided by it, I'm happy. So I have 3 easier to work with terms. 3 easier to work with problems. 27 over 6 doesn't turn out super nicely, but I can divide top and bottom by 3, get 9 over 2. I'll take my negative sign from down here and put it, I like to put it by the 9. I could also put it just in front of the 9 halves. Technically, I could leave it in the denominator. It just looks a little funny that way. We've got a positive divided by a negative, so that's minus. 6 over 6 is 1. Y squared over y is y to the first, or just y. Oops, I forgot my y term. Sorry about that. This is y to the fourth over y to the first, so y cubed. Now we go to the third term. We have a negative and a negative, so that's plus. 18 over 6 is 3. And I have a y on the bottom. So it either looks like this, or maybe I write negative 9 halves y cubed minus y plus 3y to the negative first. Those are both correct ways of writing the answer, and there are a few other ways as well. Notice that I'm writing these two equivalently, and these two are equivalent. Let's look at a few more. Example 17. Feel free to grab some extra paper if you need it. 30, we're almost done though. 30t to the fourth minus 10t cubed plus t squared minus 20 over 10 t squared. Notice when I write my t's, I make sure that they don't look like plus signs, so I kind of do a hook at the end. I'll let you work through that one, and I'll let you work through this one as well. We have 14x cubed y squared minus 6x squared y to the fifth plus 2x y to the sixth over 2x y squared. Notice that in all of these, I'm dividing by a monomial. I'm dividing by one term. We're not dividing by binomials or trinomials in this class. So the bottom, I can always split this up into, in this case, 4 terms. This over this, this over this, this over this, this over this, and then combine. You can do the same thing down here. Once you have these examples down, go ahead and take a look at worksheets on pages 113 and 114.